After John Dalton, we knew that everything was made up of atoms, but we didn't know what atoms were made of. In this section, we are going to look at the discovery of subatomic particles, that is, particles that are smaller than atoms and make them up. The first subatomic particle to be discovered was the electron. Using a cathode ray tube, J.J. Thomson discovered the electron and was able to calculate its charge-to-mass ratio. Here's a cathode ray tube like the one J.J. Thomson used to discover the electron. It is made of glass and has a cathode hooked up to a high voltage source. Nowadays, we would plug it into a wall socket. A beam shoots out of the cathode and is focused through an anode. Charged plates can be placed on either side of the tube. The so-called cathode ray is attracted towards the positive plate and away from the negative plate, indicating that the ray is negatively charged. It turns out that this cathode ray is made up of negatively charged particles called electrons. Please watch this video linked in the slides about the discovery of the electron and calculation of the charge-to-mass ratio of the electron. You do not need to know the equation in the video, but it will help you better understand the experiment that was done by J.J. Thomson. Although J.J. Thomson was able to calculate the charge-to-mass ratio of the electron, he did not know the actual charge or the actual mass in absolute terms. Those values were discovered by R.A. Millikan through his oil drop experiment. In this experiment, he was able to charge drops of oil using X-rays and suspend them with an electrical charge. From this, he was able to calculate the charges of each drop and found they were all multiples of the same number, negative 1.6 times 10 to the minus 19 coulombs. He determined this must be the charge of an electron. Please watch the video linked in the slides for more details about Millikan's oil drop experiment. By finding the charge on the electron in coulombs, Millikan was able to also calculate the mass of an electron by using J.J. Thomson's charge-to-mass ratio as a conversion factor. He found that the mass of an electron is 9.107 times 10 to the minus 31 kilograms, which is an extremely small number. Several different models were proposed about where the charged particles were in atoms. One model, called the plum pudding model, was proposed by J.J. Thomson, the same man who discovered the electron. You might be more familiar with chocolate chip or oatmeal raisin cookies than plum pudding. The electrons could be thought of as the chocolate chips or raisins within the cookie. They are individual pieces surrounded by a dough of positive charge. Another model, called the Saturn model, was proposed by a researcher named Nagaoka. His model had the electrons forming a ring around a central sphere of positive charge, like the ring that surrounds Saturn. Neither model was correct, though the Saturn model ended up being slightly closer. Ernest Rutherford finally set the record straight with his gold foil experiment. In his experiment, a beam of small positively charged particles called alpha particles shot out of a radioactive element, passed through a thin sheet of gold foil similar to the aluminum foil you have in your house, and eventually hit a detector. It was expected that if the plum pudding model of the atom were true, the atoms in the foil would not be dense enough to deflect the alpha particles, and they would all pass straight through the foil. Although most did in fact pass straight through the foil, some of the particles bounced off at different angles. It turns out that the beams that passed straight through the foil were passing either between atoms or through the mostly empty part of the atom that contains electrons. Remember, electrons are extremely small. Only the beams that were pointing at a very small portion in the center of the atom, which we call the nucleus, were able to bounce off at an angle. All of the positive charge in the atom is found in what we call protons, in that center portion called the nucleus. Remember, like repels like, so the densely packed positively charged protons were able to repel the positively charged alpha particles. The protons and electrons together did not have enough mass to account for all of the mass in an atom, so there had to be another subatomic particle waiting to be discovered. A researcher named Frederick Soddy discovered isotopes, which are chemicals with the same reactivities but different masses. He didn't know how they had different masses, though. Finally, in 1932, James Chadwick discovered neutrons, which have zero charge and about the same mass as a proton. Isotopes were determined to have the same number of protons as each other, but different numbers of neutrons, and therefore had different masses compared to each other. Here is a summary of the discovery of the subatomic particles. J.J. Thomson discovered that electrons are negatively charged, and he calculated their charge-to-mass ratio using a cathode ray tube. R.A. Millikan discovered the electron's charge in coulombs and its mass using his oil drop experiment. Ernest Rutherford discovered the proton and found that it is located in the center of the atom, called the nucleus, using his gold foil experiment. Frederick Soddy discovered isotopes by comparing the reactivities and masses of different atoms. We didn't really talk about his experiment, but James Chadwick discovered neutrons by hitting beryllium with alpha particles.